Welcome back to BAS 120-0001 online. Hey, just want to give you some updates on how we did in week 2. So had some excellent discussions on big data. A lot of folks work in the industry. That's great. I encourage you to read as many of the discussion boards as you can. A lot of really interesting folks in the class doing a lot of interesting stuff at work. The assignment answers are part of this video. They're also issued, the Excel are issued under homework answers. The quizzes in general is a pretty good class average. Your project, don't forget that. It's coming up due October the 8th. We've also added, under the discussion boards, there's an open forum where when there's questions it would be useful to the entire class to see the answers to. I've posted them. So if you have a question on the homework, or if you want to add a thread or add a question of your own, I'll be monitoring those each day. And that way, if you have a question, the whole class gets to see the answers to some of those things. So we're coming along very well through week 2. Week 3, you have in your lessons your checklist. The main thing is we'll be jumping into chapter 2. There are instructional videos out there that I hope you're finding helpful. You have a lot of study material, the PowerPoints in addition to the book. Your assignments here in lesson there are in yellow. There's an assignment, there's a quiz, there's a discussion forum, and hopefully we're getting into a good cadence of this course and it's making sense. I like to give everybody some additional learning opportunities. So in line with the big data, there's a link to a McKinsey presentation on big data, and they have the transcript down below, which the link is on Blackboard announcement for you. So let's get into reviewing the homework. You have the Excel. Problem number 7 was all about a little trouble with this one because it was a little confusing. What do these numbers in front of the variable mean? And maybe we outthought ourselves. So remember, the number in front of the variable is going to tell us, for example, the 367 times age. This tells us that the average account balance, because that's what we're predicting, increases by approximately 367 for each year increase in age. So as age goes up, balance goes up. For every 1 year increase in age, the balance goes up $367. So the variable is telling us the direction by the plus or minus sign, and it's telling us the amount of weight by what the number is, 367. Same thing throughout this. And then the second part of the question was just what I call a plug and chug. It gave you the age, the education, and the wealth, and you just substituted those in for the variables and cranked out an answer. Problem number 13 was to take a function. They gave us a demand function, D equals 20,000 minus 3P. They gave us a cost model, which was 5,000 plus 4D. Now, what we did here, if you remember algebra, we knew what D is, so to get this in one variable, we substituted this D into this function and then simplified to get a cost of 13,000 minus 12P. Now, total revenue is going to be our units demand times our price. So we know our units demand times our price gives us 2,000P minus 3P raised to the second power. And then our total cost, they gave it to us right here. We calculated it. So profit is total revenue minus total costs. And you do the algebra and you get the answer. Any question? Again, these we will be using throughout the course. So if there's something you don't understand, let me know. Thanks. Okay, let's review Chapter 1, Problem 14. This was probably the most missed one. It was a little tricky. They gave us price and they gave us demand in units. So as expected, as the price goes down, our units of demand would go up. So we know we have a negatively sloped function. Now it asks us to develop a model or a function for this. So a couple ways we could do it. We could come in here and we could say, let's plot this by highlighting that. Say insert a scatter plot. And I like this one that gives us a line. And it gives us something that looks like this. And we go, what the heck is this? Well, we have to do a little playing around with this. Notice when the chart tools come up, it gives us design, layout, and format. Let's go to redesign this guy. And let's go select data. Now, notice over here, the reason we've got two lines is we've got price and demand on our horizontal axis, which we really don't want. We want to have price predict demand. So let's move demand over to our y-axis. All I did is highlight it and said switch rows and columns and hit OK. Then it gives us this, which makes a little more sense. Here's our demand at these prices. And you can see at the $300 price, we have demand of 1,200 units. And at the $600 price, we have demand of about 500 units. Now, there's a way in Excel, if I click on, right click on this line, I get this. If I say add a trend line, a linear, and give me an equation, what Excel will automatically do is give us an equation, which is y equals negative 2.333 times x, which is the price, plus 1,900. So that's one way within Excel to do it. Another way to do it is to use algebra, which is the way I think the book shows you both ways. But so you go back, you'd have to find the slope, which as you remember is change in y over change in x, which we calculate to be negative 2.33. Then if you remember the point slope formula, y minus y1 equals m, which is the slope, times x minus x1. We can go ahead and do the math and we get y equals negative 2.33 plus 1,900. So if you're good at the Excel tools, which chapter 2 will work on even more, you can have Excel calculate the equation for you because you have 2 points, or you can use old-fashioned algebra. Now, then it says take this and develop a model and find us the price that maximizes revenue. So all I did, I broke it into two parts. I said the demand, just our demand function right there, our negative 2.33 times price plus 1,900 units gives us the units demanded. The revenue would then simply be the price times the number of units. So I then just sort of put in at random some numbers, and you can see somewhere in here between 300 and 500 and below 1,000, we are going to maximize our revenue. So I just played around with trial and error, and I came up with around 405. I think the book says 425 or the example you have. It just depends how many trials and errors you do. You can also use Solver, which is what I did here. So let me show you that. If I went to data and I've added in Solver. If you haven't added in Solver, there's a video on Blackboard on how to do that, or explanations. So I said Solver, and I said maximize my revenue, this cell right here, maximize by changing this cell right here, our price. So what Solver is doing is you're saying maximize my revenue, maximize that by changing that. By changing that. And then you just hit solve, and okay. And you see you actually get the exact number, 407 and 15 cents. That's problem chapter 1, 14. If you had any problems or questions with it, let me know, because we're going to take this supply or demand and price function, and we're going to be using it throughout the course and expanding on it. So if you don't understand it, let me know. Thanks.